Picture this. You're sitting in the exam hall. The clock is relentlessly ticking down. You can practically hear that tension-building music playing in your head. You flip the page and there it is, a massive, multi-part, 9-mark question on your Cambridge Mathematics past paper. We're talking syllabus code 9709 today, though if you're taking 0580, 0606, 4024, 4037 or 9231, listen up because the exact same principles apply to you. You are staring down the absolute heavyweight champion of the math syllabus, logarithmic and exponential functions. Today, we're acting as your strategic explainer, completely decoding the exact hidden criteria that separate a perfectly average grade from an untouchable A-star. Now, let me introduce you to two very typical students we see in the examiner's room all the time. First up, we have Alex. Now, Alex is brilliant at memorization. But under pressure, Alex panics and overloads the answer sheet with raw mathematical facts, just dumping every single logarithm law on the page with absolutely zero contextual analysis. Then we have Sam. Sam is fast, super fast, but Sam rushes the command words and completely misses the specific requirements of what the examiner is actually asking for. Throughout this session, we're going to look at their fatally flawed answers, look at the red pen marks they received, and show you exactly how to transform those responses into A-star perfection.
So let's get right to it. What actually separates a B from an A-star in 9709 mathematics? Is it just being a human calculator who doesn't make arithmetic mistakes? Absolutely not. Rather than just better calculations, the difference almost always comes down to understanding the hidden architecture of how examiners actually award marks. Think of your exam answer like a photograph. You are the photographer. You need to find the perfect angle and frame your answer to highlight the key evidence. Both of our students, Alex and Sam, know that the natural log of e to the power of x is simply x. They both know the power rule. But they're stuck at a B grade. Why is that? Well, it's because when the examiner asks them to quote-unquote evaluate a population growth model, Alex writes down an entire page of algebra without a single word of explanation. And Sam? Sam just solves for x, underlines it twice, and stops, completely ignoring the real-world context of the data. The A-star student doesn't do that. The A-star student frames their mathematical execution within a rigorous analytical structure.
And this brilliantly illustrates what the examiners themselves are practically begging you to do. Look at this quote pulled directly from the official principal examiner reports. Candidates referencing cross-topic connections achieve significantly higher marks. They are explicitly telling you that top-tier answers rely on precise definitions, causal relationships, and integration with other syllabus areas. You cannot treat logarithms in a vacuum. A truly high-level question is going to blend exponentials with calculus, maybe asking you to find the exact rate of change of a decay curve using differentiation. Or it's going to mix logarithms with arithmetic progressions. When you explicitly show the examiner that you understand how these mathematical frameworks connect to one another, you stop just scraping by on basic accuracy marks and you start racking up the massive analysis marks.
To get you into that top tier, today's masterclass playbook will systematically walk you through 4 critical areas. We're going to break down core logarithmic principles, build your procedural framework, navigate the critical examiner pitfalls, and finally, master evaluative problem solving. But before we continue and dive into these 4 steps, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now so you never miss a strategy session. All right, let's get into the hidden architecture.
Section 1. Core Logarithmic Principles. It's time to unpack the theoretical foundations and the specific cognitive domains that the Cambridge syllabus is actively targeting when they write these papers.
So, every single mark on your paper is tied to these assessment objectives: knowledge and understanding, application, and analysis. You must demonstrate mastery across these 3 distinct domains, proving you can transfer conceptual understanding to completely unfamiliar contexts. To do this, top students use something called the PEAL framework: point, evidence, explanation, link. Now, usually, you hear about PEAL in history or English, but we are adapting it specifically for high-level mathematics. Your point is identifying the correct logarithmic principle. Your evidence is substituting the specific data from the past paper scenario. Your explanation is your clear line-by-line algebraic working. And your link is tying your final numerical value directly back to the specific command word in the prompt. This is exactly where our students Alex and Sam crash and burn. Alex has great knowledge of logarithm laws but utterly fails in analysis. Sam is decent at application but rushes, totally missing the link back to the real world. I want you to look at an answer on your own page later. Does it follow PEAL? If you just know the power rule, that's not enough. You have to apply it to a complex exponential decay problem and analyze if your calculated half-life makes logical sense.
Moving into Section 2, the procedural framework. We are transitioning from theory to execution. Let's look at the standardized sequence that practically guarantees your method marks, even if you make a tiny calculator error at the very end. True problem solving requires this incredibly strict deconstruct, solve, and evaluate sequence. Step 1. Identify the given information. What are your initial conditions? Step 2. Break it into logical steps. If you are looking at an equation like p equals p sub 0 times e to the power of kt, identify that initial population p sub 0 immediately. Step 3. Execute and solve systematically. Show the examiner exactly where you are taking the natural logarithm of both sides. Don't skip that line of working. Step 4. Verify your results for reasonableness. If you calculate that it takes a negative amount of time for a population to double, guess what? You've dropped a negative sign somewhere. Stop and fix it. Finally, present your recommendations. Let's do a live 60-second rewrite in our minds. Think back to Alex's flawed answer, a jumbled, chaotic mess of numbers scattered randomly across the page. Now we apply this blueprint. We write a clear heading, we define our variables explicitly, we move step by step vertically down the page, perfectly aligning our equal signs. Suddenly, an answer that was only going to scrape 1 out of 5 marks is now confidently securing all 5 simply because the examiner can easily follow the logical flow of the mathematical argument. The red pen marks literally transform into green check marks.
Now, your data interpretation skills are going to be heavily tested here, usually with a complex chart or table. This matrix on screen maps out your exact plan of attack. You've got to practice extracting core trends from complex data. Let's say you get a question with a table of experimental values for x and y, and the examiner asks you to show that they follow a relationship of the form y equals a times b to the power of x. Your first step is the data scan. Extract the base numbers. Then, the relationship check. This is where you have to connect the variables by linearizing the data. You take the log of both sides, giving you log y equals log a plus x times log b. Now you can plot log y against x to get a straight line. You calculate the gradient to find log b, and you find the y-intercept to get log a. It's brilliant. Finally, your evaluation requires you to draw conclusions and interpret those specific constants right back into the original exponential model.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 whole grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, looking at this slide, mastering these strict formatting conventions is exactly how those students make those massive leaps. Clear annotation isn't just about having pretty handwriting, it's about communicating your mathematical intent. When you use correct terminology, actually writing the words, taking the natural logarithm of both sides, you are actively locking in those method marks.
Welcome to Section 3 Critical Examiner Pitfalls. It's time for our interactive workshop. Let's dive deep into the tension points and highlight the exact danger zones documented by principal examiners that cost students easy marks every single year.
Across thousands and thousands of scripts, examiners see the exact same patterns of failure. There are exactly 3 major mistakes repeatedly highlighted for logarithmic and exponential functions. Knowing these in advance is basically a legal cheat code for your exam.
As visualized right here, the absolute most frequent errors are providing generic answers, confusing cause and effect, and forgetting to check final formatting. All right, it's time for Challenge 1, the data scan. Imagine a complex mathematical chart popping up on your screen right now, tracking exponential viral spread. I'm putting 60 seconds on the clock. Go. What is the core trend? Well, Sam, our rushing student, would just look at it and write, the line goes up. Guys, that is a generic answer. That is the #1 error on this chart. An A-star student uses their 60 seconds to scan the data and writes, the rate of increase is directly proportional to the current population, indicating a continuous exponential growth model governed by a equals a sub 0 e to the power of kt. Boom. Do you see the difference? You avoid the generic trap by wielding specific, technical, mathematical vocabulary.
Let's move straight into Challenge 2, Find the Flaw. I'm going to read you a flawed sample paragraph, and I want you to spot the sentence that is bleeding marks. Here we go. The equation was simplified using log laws. The value of t is 5.3. Therefore, the log graph crosses the axis. Okay, time's up. What's the fatal flaw? The maths might be perfectly sound, but it is completely generic. You must always link your calculations to the context. The A-star context-specific answer looks like this. The calculated time t equals 5.3 years represents the exact moment the financial investment depreciates to half of its original value, as modeled by the exponential decay function. You are taking the abstract number 5.3 and anchoring it to the reality of the scenario. That's how you get the final mark.
And to avoid confusing cause and effect when the clock is ticking down, you need a system. Here is challenge 3, speed writing. But before you write, you need a memory hack. Create a mnemonic for your log laws. For example, PQP, product, quotient, power. When you turn the page and see a terrifying, massive algebraic fraction trapped inside a natural logarithm, panic sets in, right? But with PQP, you breathe. You write PQP in the margin, and you systematically deconstruct it. First, the quotient law, to separate the numerator and denominator with subtraction. Then the product law, to split multiplied terms with addition. Then the power law, to bring those exponents down to the front. This one psychological anchor prevents the algebraic confusion that ruins 75% of standard scripts.
Finally, Section 4, Evaluative Problem Solving. This is the A-star difference. This is how we push your mark potential from 80% straight to 100%. Let's elevate your mindset.
Top-scoring candidates do not just calculate blindly. They demonstrate evaluative thinking. They question assumptions, they consider limitations, and they justify every decision. Let's say you're doing a question modeling the cooling of a cup of coffee using Newton's law of cooling, which involves an exponential decay function. Finding the cooling constant K is just the basic math. But the very last 2-mark question on the page might ask, state one limitation of this mathematical model for very large values of time t. Evaluative thinking is realizing that pure math might say the temperature approaches 0, but the physical reality is that the coffee cannot drop below the ambient room temperature. You have to question the mathematical assumption against the real-world boundaries. If you can do that, you are thinking like an A-star candidate.
When a question asks you to compare, say, comparing a linear growth model with an exponential one, you need to use this comparative analysis checklist. You have to systematically identify both similarities and differences, and you must use comparative connectives like whereas, conversely, or in contrast. This explicitly signals to the examiner that you are analyzing, not just listing facts. So what is our ultimate final system? 3 rules. Number 1, command word decoding. Know exactly what evaluate means versus solve. Number 2, apply the PL framework for your written explanations. Number 3, the time management matrix. Do not spend 12 minutes on a 3-mark logarithm derivation and leave a 9-mark modeling question blank.
So, it all comes down to this final provocative question. When you walk into that exam hall, will you be like Alex and just rote memorize formulas, or will you evaluate the evidence, frame your answer perfectly, and secure every single mark available? Students who implement these exact mathematics strategies see an average improvement of 2 full grade boundaries. But that is only if they practice consistently with our weekly videos. So here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCS and click that bell. Don't let another exam pass you by. Drop a comment below right now with your target grade for mathematics and the absolute biggest challenge you are facing with logarithms. Our team responds to every single comment. Like and share this video with a study partner who needs it. Ace the Exams. Your Cambridge success starts here. Keep analyzing, keep evaluating, and I will see you next time.